and welcome to this session on Determine the efficiency of three-phase squirrel cage induction motor by no-load test and blocked rotor test. Let's begin with the session.
Let us now take a look at the objectives of this session. At the end of this session, you will be able to conduct a no-load test for a given three-phase squirrel cage induction motor. Conduct blocked rotor test for the above three-phase squirrel cage induction motor. Calculate the efficiency of the motor. The equipment and the instruments required for conducting this test are three-phase squirrel cage induction motor with brake loading arrangement and spring balance, three-phase auto transformer, triple pole single throw TPST switch, MI voltmeters, MI ammeters, tachometer, dynamometer, type wattmeter, connecting wires. Since the stator current is mainly magnetizing in nature, in no-load test, the current is highly inductive in nature. Therefore, the power factor is very low under the no-load test. A low power factor, LPF wattmeter, is required in no-load test. In blocked rotor test, full load current flows through the wattmeter and therefore a unity power factor UPF type wattmeter is used. Once the meters are selected, the circuit need to be rigged up as per the circuit diagram for no-load test. From a three-phase AC supply, wires are connected from each phase to the input side of a TPST switch. The output of the TPST switch is connected to three-phase auto transformer. Voltmeter is connected to measure the line voltage between R and Y phases, and the ammeter is connected to measure Y phase current. Two wattmeters are used in the circuit to measure the three-phase power. The current coil marked as ML is connected in series with the phase, and the potential coil CV is connected between the phases. The terminals M and C are short-circuited. The stator phase windings of the motor are connected to the output of the auto transformer through wattmeters and ammeter as per the circuit diagram. Switch on the three-phase power supply and close the TPST switch. Slowly turn the knob of the auto transformer towards the right, observing the right voltmeter reading till it reaches the rated voltage of the motor. The motor slowly starts picking up the speed and reaches its rated speed. If any of the wattmeter reads negative, switch off the supply, bring back the circuit to initial condition, and then interchange the connections of the current coil M and L terminals of that wattmeter and repeat the experiment. The reading of that wattmeter needs to be treated as negative. Now, let's note down the voltmeter, ammeter, and wattmeter readings and tabulate. Based on the range of the instruments, appropriate multiplication factor has to be considered while recording the readings. Switch off the supply and disconnect all meters and connections from the motor. Measure the resistance of the stator using a low voltage DC supply applied between the two ends of a stator winding. A voltmeter of MC type 0 to 30 volts range can be connected between the stator terminals, and an ammeter of MC type with 0 to 2.5 amps range can be connected in series with the stator winding. The meter readings can be recorded and tabulated in this table. If the stator windings are connected in star mode, resistance per phase Rp is equal to V by I into 1 by 2. Therefore, Rp is equal to R by 2. If the stator windings are connected in delta mode, resistance between two terminals R is equal to V by I. Let the resistance per phase is equal to Rp. R is equal to Rp parallel to 2Rp. That is, 1 by R is equal to 1 by 2 Rp plus 1 by Rp. Resistance measured is equal to 3 by 2 Rp. Therefore, Rp, resistance per phase of stator, is 2 by 3 R. Let's calculate the no-load losses from the readings taken during the no-load test. The losses during no-load are I square R loss in the stator winding, core losses in the stator and rotor, friction and windage losses. No-load copper loss is equal to 3 into I naught pH square into Rp is equal to 3 into 1.5 square into 2 by 3 into 7.14. This is equal to 27.98 watts, where I naught pH is the per phase no load current. For star connected motor, I naught phase is equal to I naught. For delta connected motor, I naught phase is equal to I naught by root 3. Core losses, friction and windage losses practically remain constant in induction motor. Constant losses is equal to W naught minus 3 into I naught phase square into Rp. This is equal to minus 100 plus 150 into 2 minus 27.98 equal to 72.02 watts, where W naught is the no load input power. Keep the rotor in blocked position. Switch on the mains and close the TPST switch. Rotate the auto transformer knob till the ammeter reads full load current. Observe voltmeter reading and wattmeter readings. Tabulate the meter readings in the table shown. The supply can be turned off now and remove the meters and connections from the motor. Let's see how the calculations work. To recap, we have learned to conduct a no-load test for a given 3-phase squirrel cage induction motor. Conduct blocked rotor test for the above 3-phase squirrel cage induction motor. Calculate the efficiency of the motor.
So that's all about the determine the efficiency of 3-phase squirrel cage induction motor by no load test and blocked rotor test. See you in the next session.